Hello, and welcome to our second lecture on antimicrobials. This is where we really kind of piece all of our early chapters together and connect them with our later chapters. Why did we need to learn about a ribosomal subunit for bacteria and why they were different from us? Why did we need to learn about what makes up a cell membrane? Why did we need to learn up DNA and RNA and all that good stuff? Well, this is actually where it gets interesting because we need to know that for this next table. Okay, these are the 6 mechanisms that you should know for our purposes in the class. Unfortunately, it doesn't really show up well in the slides I see, well, in the video, but be sure to look at the PowerPoint while you're listening to this video, and it should be easy to read than it is now. Okay, but either way, we have 6 different modes of antimicrobial action. Okay, and so let's take a look. All right, I'm going to start in the middle of this list because number 4 is a great example of why we have broad spectrum drugs. Okay, so number 4 reads inhibit nucleic acid synthesis. Okay, and we can either target RNA synthesis or DNA synthesis. Okay, now when I think about that, I think, okay, well, we've had DNA and we have RNA in all of our species that we've seen, right? That's actually what defines it. We even have them in viruses. Okay, so if we have DNA and RNA everywhere, this kind of drug is going to be a broad spectrum drug in that it will target our cells, it'll target bacterial cells. Okay, so this mode of action is very, very broad spectrum. Okay, and one of the ones that you're going to want to know is these fluoroquinolones. Okay, a fluoroquinolone is going to inhibit DNA synthesis. Okay, and that is one of the ones you're going to want to know. Okay, because that one is a common type of drug. When you have a strong infection, you're going to provide a fluoroquinolone after just to make sure, because it is a DNA inhibiting drug. Okay, and so we also have antimetabolites. Okay, they can disrupt places in synthesis of enzymes. I feel like those would be more narrow spectrum. Okay, and then we also have mycobacterial ATP synthase. Okay, so we can get the mycobacteria and we can target their ATP synthase. So this would be a narrow spectrum. Okay, so those are the 3 kind of that we're starting with, because the top 3 are the main ones that we want to talk about. Okay, so these ones are where we're really getting in to see why we need to learn the parts of the cell that we did. Okay, so we can inhibit the cell wall biosynthesis. Okay, now we all know what the cell wall is in bacteria now, right? We have a gram stain. We can see that it's gram positive, and we can see that it is gram negative. But the main thing that we can know is it has peptidoglycan, and what don't we have is peptidoglycan. Okay, so we can target peptidoglycan subunits and peptidoglycan transport. Okay, and we can also inhibit the cell wall using penicillin. Okay, and that's how penicillin works. Okay, so penicillin was an accidental discovery, and he did not mean to discover it. He put his petri dishes got moldy and grew with his bacteria, and he realized where they met, they did not grow, and so he sensed that the fungus produced a toxin to the bacteria, which made it not grow. He was right, and a couple of scientists after Fleming really ramped it up, and now we have fake or manufactured penicillin. Okay, And so this class is called beta-lactams. Okay, penicillin is called a beta-lactam. All right, so beta-lactams are the ones that are going to inhibit cell wall synthesis. That would be an important one to remember. Knowing that we now know peptidoglycan is in the gram stain, we also know that we can target it for destruction that way also. Okay. Then we know we can also target their ribosomal subunits. Okay, we know that they have a different ribosome than us, so we can target their ribosomes. And if we target their ribosomes, they can't make protein, they can't live. Remember, I've stressed protein are the doers, they're the ones who do the work. So if we don't have protein, we don't have ribosomes, we can't do any work, we're going to die. All right, and then finally, why did we need to learn the phospholipid bilayer so much? Well, because we want to disrupt that membrane. Okay, that membrane is a good way to get rid of bacteria too. If that membrane ruptures, you lose all your cell contents and you die. Okay, so those are the three ways that we can do it. Okay, and let's kind of go over them a little bit more. All right, so if we want to attack the cell wall, we are going to use a beta-lactam or a penicillin, and we are going to attack that cell wall. Okay, several different classes do this. Okay, and we are going to stop the synthesis of peptidoglycan. Okay, all right, and remember, humans don't make peptidoglycan, so it's an excellent example of selective toxicity. Okay, targeting the protein synthesis. Okay, remember, they have different ribosomal subunits than us, so we can target these just fine and not hurt ourselves. Again, another good selective target for antibacterial drugs. And then finally, we can disrupt the membrane. Okay. Unfortunately, this mechanism is not selectively toxic. Okay, and these drugs can also damage many membranes of the kidney and the nervous system. Okay, so even though we have all these drugs, we need to take into account a lot of different factors. Okay, not just the drug and the bacteria, but also the past and what the patient also can take also. Okay, so we get to this fancy dancy list, okay, of antibiotics, antifungal drugs, antiviral drugs, and antiparasitic drugs. Okay, and you might be like, well, how am I going to memorize all of these? You don't really have to memorize them, is why. Okay, you can kind of like get a good feeling for them, and I know that's kind of easy to say, but anything ending in "cillin," okay, is going to be antibacterial. Penicillin, amoxicillin, you already know that one. All right, so anything with quinolones is going to be that fluoroquinolones that we were talking about. Okay, those are going to be antibacterial as well. All right, and so then we go into antifungals and we look at another ending, azoles. All right, and now, yeah, you'll see azoles down here as well. Um, and they can be used for parasites, but the question won't have you confuse the two. And I like to learn azoles as antifungals: mucoconazole, fluconazole, ketoconazole. The azoles are a large class of antifungal drugs that it's worth memorizing, and if you have any at home, you'll see the azole name everywhere. Okay, antiviral drugs, okay, don't really exist for like the common cold and even COVID, right? We have to get immunized for that. That's later. But we do have some antiviral drugs, and those tend to end in VIR. Okay, you can see acyclovir, ritonavir, oseltamivir. Okay, and so those VIR drugs are antivirals. So now we have a few built up, and we say, what would you prescribe for a yeast infection? Amoxicillin, penicillin, ritonavir, and fluconazole, right? We kind of already can tell based on our endings that we would choose fluconazole because the other ones don't make sense to target bacteria and one targets a virus. Okay? Then we have antiparasitic drugs. Again, like I said, The azoles are there too, all right, but you won't have a double question like that with the answer like that. Okay, and to wrap up before the next video, we just need to look over the good and the bad. All right, so we have some pros when taking some treatments, and we have some cons when taking treatments. And I'm sure we all kind of have seen this before when we take a medicine. Ooh, that one really knocked me on my butt. Those kinds of things, right? So we really want to treat the infection, right? That's the main goal. We want to treat the infection, otherwise we wouldn't even be taking the drug. And most of the time it's that bad. I just want to get better. Okay. We can also take some to prevent infections. Right. We can do like PrEP. Would stop some things like that. That's for HIV. But there's also some cold and flu type drugs you can take before that you might think if you're going to be exposed to them. Decrease disease transmission, that's obviously the case. If we treat it before you spread it, improve quality of life, get it out of me, right? All right, but then we have the cons. All right, are you going to throw up? Do you have an allergic reaction? Okay, did we prescribe you antibiotics when you had a cold and now all of your bacteria are resistant? And did we make your gut bacteria go down so much that you now get C. diff? It happens. And did we price you out where now you just have to pay for the rest of your life to get treated? So these are the questions you need to think about, kind of like the ethical quandaries we had in previous chapters that are interesting to think about. And so when we prescribe treatment, you'll see it's not just patient and drug, and we really need to think about that. All right, so in the next video, we'll see how we kind of piece it all together and how we would prescribe some antimicrobials. Okay.